Right, so by this time we made headway into electrodynamics. Now, one pertinent issue which you may have witnessed in my DVD and which I left for you to ponder over for a while. I wanted some residence period on that issue and promised to come back to it in the midst of all of electrodynamics. And I'll take this opportunity to have a quick word on that issue. If you recall, way back when you saw the DVD on magnetics, we examined and investigated the Lorentz force, the magnetic force Q into V cross B, acting on a charge Q, moving with a velocity V when exposed to a magnetic field B. That's the magnetic force then. And then this suggested that this force was perpendicular to the velocity, and therefore F dot V was 0. The power associated with the magnetic force was 0, and therefore the magnetic force was never instrumental in producing work, and therefore never participated in change in kinetic energy, so to say. All that it ever did was it changed the direction of velocity of the particle, but never actively participated in change of magnitude of the velocity, right? Now, ever since this concept was put across to you, you must have your belief in this concept must have wavered significantly. It must have swung from one end of the spectrum to the other, and you thought it was so perverse to even believe that magnetic force is not doing work, given the fact that in daily life you see an electromagnetic crane lifting objects, raising them to a height by means of the magnetic force. Who then is doing the work? And then while we were solving some mundane problems on electromagnetism, we looked at magnetic force acting on a current carrying wire and instrumental in doing work, and so many other instances perhaps that for us to deny that magnetic force is doing work is it seems like a very outlandish concept. But it then becomes a matter of little bit of subtlety to examine what's happening internally. Not rocket science, but a quick simple understanding of what might be happening so as to figure out that, well, indeed magnetic forces are not doing work and it's coming from somewhere else. Some other agency is actually manifesting itself in the form of work done by magnetic force. Let me quickly brief you on that count. Now, let's say there was this current carrying conductor placed in an orthogonal magnetic field. Uniform for the sake of understanding. And if L was the length of this conductor, then you might have realized that BIL was the magnetic force that it got exposed to. DL, B, so DL cross B was upwards, right? So BIL was the magnetic force that it experienced, right? In the process, this magnetic force could have caused the wire to get risen to a certain height, could have got the wire to have got risen to a certain height, and if it got, so this was F magnetic, And if it got risen to a certain height, then it seems like the magnetic force has done work into height. That seems like the work done by the magnetic force. That seems like the work done by the magnetic force. Yes or no? Then how on earth do we counter the fundamental about, how on earth do we really express solidarity towards the fundamental relating to magnetic force not doing work, given such a blatant expression on work done by a magnetic force, right? Okay. Now, what really happens is that while this current was driven through this conductor, the wire developed an upward velocity. And the charge carriers had a velocity, let's say W. The charge carriers had a velocity W along the wire. Now, the net velocity of the charges is a consequence of the resultant of U and W. The resultant of U and W would offer the net velocity, right? Now the magnetic force that we've been talking of would actually be perpendicular to this velocity, would actually be perpendicular to the net velocity. This magnetic force would be perpendicular. The net magnetic force would be perpendicular to the velocity v, like this, parallel to this. Right? Now, this magnetic force, net magnetic force, has two components in it. QWB perpendicular to W, right? QWB, right? This is W, this is B. So QWB perpendicular to W, and a QUB perpendicular to U. A QUB, U is like this, B is like this. So QUB, Q into U cross B would be leftwards. So QUB, which is perpendicular to U. Let's say Q is the total charge on this. Q is the total charge along the length of this at any given instant of time. And this perpendicularity with V establishes that there is indeed no work done by the magnetic force. Now, going a little further, what is happening? This F net is the resultant of this vertical component of the magnetic force and the horizontal component of the magnetic force. When the whole thing gets risen to a height h, let's say a height h, first of all, if W is the velocity of the charge carriers along the length of this conductor, then the current I will be some lambda times W, will be proportional to the velocity of the charge carriers, isn't it? The current here would be proportional to the velocity along the conductor, would be proportional to the velocity along the conductor. What is lambda? Lambda is the charge on this per unit length, is the charge on this per unit length. See, if Q by L into W is the charge per unit length. See, charge per unit length into velocity into meters per second will give me charge per second. Yes or no? Charge per unit length into meters per second will give me charge per second, which is the current. I hope you are comfortable mentally with this. So this is the current. This is Q over a length L, right? That's lambda. Now this on getting raised to a height h, vertical height h, this component of the magnetic force, is doing a certain amount of work. What work? The work done by the vertical component, of the magnetic force is QWB, height h to which it's raised, right? Where Q into W is I into L, right? So I into L, so this becomes BILH. Which is the work done by the vertical component of the magnetic force, right? Now, what does this horizontal component of the magnetic force do? This horizontal component of the magnetic force is opposing or impeding the charge carriers, right? It's opposing the current I, so it's impeding the charge carriers, it's resisting the motion of the current. QUB is opposite to I, so it's resisting, which means what? This would have to be overcome, right? For the current to still flow past it, this magnetic force would have to be overcome. This current must flow in a manner so as to overcome this. Who will overcome this? The source which is driving the current. It could be a battery or a generator. Which would overcome the opposition offered by the horizontal component of the magnetic force. Clear? Now, which means the work done by the battery or the source, must really be good enough to overcome this, Now, the force therefore that the source exerts must be QUB and to the right. The force that the source exerts must be, source or the generator must be QUB to the right. Yes or no? So then the work done by the source, first of all, QUB is the force that the source, that is the battery or the generator, must exert in the rightward direction so as to overcome the horizontal impediment of the magnetic force, right? This QUB rightwards in a small time dt, the displacement would be W into dt along this, right? So then this must be the work done. By the magnetic force, by the source. This must be the work done by the source. Now, U into dt. U is the vertical component of the velocity into dt is the height through which the wire rises. Yes or no? U is the vertical velocity into dt. That's the displacement of the wire in the vertical direction, and therefore the height to which this rises. Yes or no? Sum of all the UDTs. So then U into dt, so this you can write as QWB, and U into dt is the height h to which the wire rises, right? And then like before, Q into W is I into L, So that makes it BIL into H. Hey, the work done by the source is this, which actually manifested itself in the work done by the vertical component of the magnetic force. See, BIL into H is the work done by the source. So this energy that you are seeing is actually coming from the source, manifesting itself in the work done by the vertical component of the magnetic force. This vertical component of the magnetic force is only a passive agency which is translating the horizontal work done by the source into a vertical displacement. It's a passive source. It's a passive source translating the horizontal energy disposition into a vertical displacement. This is where it comes from. This is how it originates. This comes from the source, as you can readily see. It comes straight out of the source, manifesting itself into the vertical displacement. So this was the extent of subtlety involved. This was the extent of subtlety involved in the whole thing. The energy that BILH actually came from the source. It got represented as the work done by the vertical component of the magnetic force. That's all. That's all. Right? So the work BIL into H was not done by the magnetic force, was not done by the magnetic field. It was done by the source. It was done by the source. And so the whole idea is still very consistent, that the magnetic force didn't do work at all, right? No work was done by the magnetic force. Or the other way you could look at it is, well, this did a work BIL into H, this in this direction did a work minus BIL into H. The net work done was 0. So consequently this force rendered itself perpendicular to this velocity. Right? So in all those cases where you would be tempted to believe that it's the magnetic force that's doing work, the idea is very similar to what I have described in this situation. So not weirdly different from this. All right. In fact, if I could attempt to give you a mechanical analogy to this idea, I'll try and do that and see if you can assimilate that idea. Let's say there is a ramp, a smooth, frictionless ramp. Let's say there is a smooth, frictionless ramp. And a body rests on the ramp. A body rests on the ramp. You apply a force, a horizontal force on the body. What happens to the body? The body moves up. The body moves up, right? The body moves up the ramp, isn't it? Now on this, realize that there is a normal force acting. There is a normal force acting in addition to the external force F. There is a normal force N acting. Now evidently when this moves up, there is a vertical displacement produced, right? There is a vertical displacement produced. There is a vertical displacement produced. Now N by itself is not doing any work because N is perpendicular to the displacement. N is perpendicular to the displacement. But look at the vertical component of N. the vertical component of n is indeed doing work. The vertical component of n is indeed doing work and is causing the height to be raised, in causing an elevation of the body, right? What about the horizontal component of n? The horizontal component of n is countering f, or rather f counters the horizontal component of n. So then fictitiously it might seem that n is doing work. No, the work is still done by you, f. N is only translating your horizontal efforts into a vertical direction. N again has a passive role to play. N is not doing work. It's only translating your horizontal efforts into a vertical displacement. It acts as an agent and intermediary. N acts as an intermediary and falsely promotes to a naive observer or naive reader that n is doing work, because the vertical component of n has resulted in a vertical displacement. So this is like the source. This is like the magnetic field BIL, which was apparently doing some work. This was the actual magnetic force. The horizontal component was countered by the force because of the source or the cell, and so on and so forth. So this, in a certain sense, and in a little bit of a loose sense, might represent a simile between the electrodynamic situation and the mechanical situation. Then, you know, the idea is almost the same idea. N again is an agent which is translating the efforts of f into a vertical displacement. The work is done by f, not by n anyways, because as you can see, the net displacement is perpendicular to n. So n has not done any work. Same with magnetic forces, almost the same with magnetic forces. Got me? Alright, so by this time you must have made some headway on this sheet on electromagnetic induction. Alright, so in this state, steady state conditions were already accomplished by the circuit, which means under steady, by the time it was t equal to 0, it started for t less than 0. By the time it was t equal to 0, there was already steady state prevalent in this circuit. That means the inductor element had become friendly to current and was not impeding the flow of current at all, right? It offered no resistance. If it offered no resistance, that means this entire E fell across this as well as this, right? And then this E falling across this, the only resistance that it encountered, this was the solenoid, right? The only resistance that it encountered across this branch was small r, and therefore produced a current I naught equal to E by small r is the current that was flowing at time t equal to 0 through the upper branch. What was the current flowing through this branch? E by capital R. E by capital R. I naught prime was E by capital R through this branch. The two currents confluenced here and made their passage through the battery, again got bifurcated here, and this continued. That was the steady state scenario in this circuit, right? Now, the moment you disconnect the switch, the moment you open the switch here, this current through the resistance dies out instantly. I mean, this had this path. The moment this path was opened up, this will die out instantly. Current through a resistance will die out right away. But this inductor has inertia. The inductor has inertia. There is energy in this inductor, half Li naught squared, and it's not going to fade away right away, right? It's not going to fade out instantly. What really then happens is that this current I naught finds a bypass circulation through this upper loop, and the half Li naught squared gets progressively dissipated through small r and capital R. The half Li naught squared gets progressively dissipated through small r and capital R, causing again a progressive depletion of current through the upper loop, and the current dies out in a period of time, right? So then this upper loop at time t equal to 0 had an initial current I naught, which is E by small r, and then what resulted beyond this point was decay of this current in a LR circuit where the R was R plus small r plus capital R was the R of this decaying circuit, right? So the decay characteristics in a LR circuit would be given by, so the current versus time at any given instant through this is going to be given by I equal to I naught e power minus t into R plus small r by L. This would be current time characteristics. For t greater than 0, this would be the current time characteristics in the upper loop. The decay characteristics, starting with I have discussed decay characteristics in a LR circuit, right? So this is the decay characteristics where I naught is E by small r, right? Now, the next part of the problem is the amount of heat generated in the solenoid. Heat generated in the solenoid means heat generated in small r. That's the solenoid. This is part of the solenoid. So the heat generated in small r will be the heat generated overall, right? For sure, the total amount of heat that is generated in small r and capital R together is the energy stored in the magnetic field, because eventually the current dies down to 0. So all half Li naught squared must have surfaced as joule heating of small r and capital R, right? So the total dissipation that takes place up to complete decay of current, complete loss of current, is like a half Li naught squared. Half of Li naught squared is the total loss of energy through small r and capital R, and out of this some gets designated to small r, the rest gets designated to capital R. The heat generated will be proportional to the resistance, right? That means heat through this divided by heat through this will be heat through small r divided by heat through this by heat through this would be small r by capital R, right? So that means the heat through this will be into small r by small r plus capital R. It will be proportional to this. Heat through this would be small r by small r plus capital R. Yes or no? Right? That's the heat through small r. What's the heat through capital R? Heat through capital R, again a proportion of half Li naught squared. What proportion? The proportion R by small r plus capital R will get dissipated through this resistive element. So that the total heat, if you add the two, it will be R plus R by R plus R.